Good day everyone. Today we will learn about chapter 5 in Form 4 chemistry, which is the chemical bond. So before we start the class, let me introduce the teachers that involved today. My name is Fujing En and my group member are Dang Kitai, Changaman, Nazwa Shakira and also Go Chiu Fong.
In the end of this chapter, students are able to explain the basics of compound formation, understand the formation of ionic bond, covalent bond, metallic bond, hydrogen bond, and dative bond, able to give examples for each bond, and able to differentiate all the bonds. We will learn 5 types of bonding in this chapter, including ionic bonding, covalent bonding, metallic bonding, hydrogen bonding, and dative bonding.
First, let's learn about ionic bonding. The ionic bond is also known as electrovalence bond. You can highlight for this part. How do we know the element is ionic bond? So, ionic bonds are formed by one atom transferring electrons to another atom to form ions. Ions are atoms or groups of atoms which have lost or gained electron. Hence, ions of opposite charge will attract one another by strong electrostatic force, thus creating an ionic bond. When positive and negative ion join to form an ionic compound, the total number of electron lost must be equal to the total number of electron gains. For an easy understanding, metal atom donate valence electron to form positive ion, which is cation. When atom donate an electron, it become positively charged because number proton more than electron inside. While non-metal atom gain electron from metal atom to form negative ion, which is anion. When atom receive an electron, it become negatively charged because electron number more than proton number.
So next we will learn about the covalent bonding. Covalent bond formed by the atoms sharing electrons to form a molecule. To achieve the octet electron arrangement, which means the 8 electrons surround the outer electron shell of atoms, and it usually occurs in non-metallic elements. Now we look at the example of the single bond, which when two atoms share a pair of electrons. In this case, both of the chlorines need an extra electron to get a full outer shell. So what they can do is they each share one electron of their own, so that together are two electrons being shared. And there are only one pair of electrons to connecting the each chlorine atom. This is called a dot and cross diagram. Next example is double bond, which two atoms share two pairs of electrons. Oxygen atoms need two more electrons to fulfill the octet rule. So each oxygen atom shares two electrons in the outer shell to form O2 molecule. There are two shared pairs of electrons in the middle where the shell overlap, means that the oxygen molecule has two covalent bonds connecting each oxygen atom and is called a double bond.
So class, now we will move into the third bonding, which is metallic bonding. Metallic bond is a strong positive force that attract metal atoms together in lattice structure. Metal atoms are arranged closely packed and orderly in the solid state. Valence electrons of metal atoms can be donated easily and delocalized although in the solid state. All delocalized valence electrons can move freely between the metal and form a sea of delocalized electrons. The electrostatic attraction force between sea of electrons and the positive charged metal ions form metallic bonds. The properties of metallic bonding is they are a good thermal and electricity conductor. When the electrons of the metal ions are delocalized in the sea of electrons, the charge from the negative terminals are carried to the positive terminals when electricity is supplied. Besides that, the metals with metallic bonding will have high melting and boiling points.
Now, I'm going to talk about the hydrogen bond. Hydrogen bond is an attractive force between hydrogen atom which bonded to highly electronegative atom with another highly electronegative atom. The examples of highly electronegative atom including fluorine atom, oxygen atom, and nitrogen atom. One of the examples of molecules which can form hydrogen bond with each other was shown in the picture on right hand side, which is water molecule. The hydrogen atom in water molecule is bonded to highly electronegative atom, which is the oxygen atom, and it is also bonded to oxygen atom of another water molecule. So, it can form hydrogen bond with each other. Do you know why our hair will stick together when it is wet? It is because, in the presence of water molecule, the hydroxyl group from protein molecule in our hair, which contain highly electronegative oxygen atom, can form hydrogen bond with the water molecule. And this will cause our hair to stick together.
Lastly, let's look at the dative bonding. Dative bond, also known as coordinate bond. A dative bond is a type of covalent bond where the electron pair is shared by one atom only. This bond is formed when one atom, known as the electron donor, provides both electrons for the shared pair. The other atom, known as the electron acceptor, simply accepts this electron to form the bond. Now, let's look at the illustration on the right. Here, we see a visual representation of the dative bond formation. The electron donor, shown in yellow, has an extra pair of valence electrons. The electron acceptor, shown in purple, does not have enough electrons to achieve a stable electron configuration. The electron donor provides its extra pair of valence electrons to the electron acceptor, forming a coordinate bond. To make this concept clearer, let's use an analogy. Imagine Emily and Sarah are two friends who are both feeling cold. Emily has a blanket, but Sarah doesn't. Emily decides to share her blanket with Sarah, so they both can feel warm and cozy. In this analogy, Emily is like the electron donor and Sarah is the electron acceptor. The blanket represents the pair of electrons.
We have finished learning the chemical bond, so it's time to do some class activity to test our knowledge. So we will do Padlet to test our mind. Class, please scan the QR code for the class activity. For the Padlet, you are required to provide examples for each chemical bond. Have fun!
That's all from us. Thank you.